What makes an airplane a jet? A jet aircraft seems easy to recognize. A jet aircraft doesn't have a propeller. Everybody knows that. A propeller accelerates air backward. A jet engine accelerates its exhaust backward. In both cases, the airplane moves forward. So, what exactly makes one airplane a jet and the other not? The answer is not how thrust is created. The answer is how power is produced. At first glance, a jet engine and a piston engine seem completely different, yet they are solving exactly the same problem. Both are internal combustion engines. Air is compressed, fuel is added and burned. The expanding gases produce useful work. The difference is how the machinery gets the job done. A piston engine compresses air inside cylinders. The expanding gases push on pistons. The pistons turn a crankshaft. Simple. A gas turbine engine does exactly the same job in a completely different way. Air is compressed by a compressor. Fuel is burned continuously. The expanding gases pass through a turbine. The turbine extracts power. The goal is exactly the same. The engineering solution is different, and that difference changed aviation. For decades, aviation was chasing speed. Aircraft were flying faster and faster. Piston engines were becoming larger, heavier, and more complicated. Gas turbine engines offered a remarkable advantage, much more power for much less weight. The result was the jet age. Aircraft became faster, much faster. But after a while, another question appeared. Was speed the only thing that mattered? Passengers like speed, but they also like affordable tickets, and airlines like affordable fuel bills. Engineers began looking for more efficient ways to use the power already available inside a gas turbine engine. Instead of sending all that energy out through the exhaust, could some of it be used elsewhere? The answer was yes. A turbine can extract power from the gas flow and deliver it elsewhere, to a propeller, to a helicopter rotor, or to a giant fan. The gas turbine engine remains largely the same. What changes is the way its power is used. And this created an entire family of engines: turbojet, turbofan, turboprop, turboshaft. In aviation, engineers carefully organized the family tree. Every branch received its own name. Outside aviation, things became much less formal. Install the same gas turbine engine in a tank, and nobody invents a new category. It simply remains a gas turbine engine, which is exactly what it always was. The engine did not change, only the way its power was being used. And suddenly the distinction between jet aircraft and propeller aircraft begins to look a little different. A turboprop aircraft has a propeller, but its engine is a gas turbine. A modern airliner has no propeller, but most of its thrust comes from a giant fan. One airplane looks like a propeller aircraft, the other looks like a jet aircraft, yet both rely on remarkably similar ideas. Perhaps the familiar distinction between jet aircraft and propeller aircraft is not quite as clear as it first appears. One classification describes how power is produced, the other describes how that power is used, and sometimes those classifications overlap. The physics never changed. Air is accelerated backward. The airplane moves forward. What changed was the engineering. And engineers became remarkably good at finding new ways to use the same old laws of physics.